Hello everyone, you're welcome to Way tutorial. In this video we are going to learn about shear force and bending moment. And this is episode 1, and in this episode 1 we are going to focus more on simple supported beam. Remember, this is Boy's tutorial. So shear force and bending moment, the episode 1. Let's see what we have. Okay, now this is our example for episode 1. We have a 20 kilonewton downward, and also our both reactions, reaction A and reaction B, which is unknown, on a distance of 6 meters. Okay, our 20 kilonewton is at the middle, therefore we have 3 meters at both sides, making it total of 6 meters. Okay, now before we can go further to understand what shear force is all about, first of all we need to look for our reactions. And for you to find your reactions, we need to use the law of static. Now, using the law of static says that the at sum of force in x is equal 0. Therefore, the force is going to the my left hand is equal to, because the force is going to my right hand. Sum of force in x is equal 0. Therefore, it means the force is going at the left is equals to the force is going at the right hand side. So if you look at our diagram, our example here, you will notice that there is no force direction, there is no force going the x direction. Then talking about the sum of force in y, which means the upward force is equals to the downward forces. So this is our coordinate. You can also use the coordinates to work on this problem too. Now, if we check the sum of forces going upward, we have our RA and also our RB, and we have to sum the both of them together. That's why we have them here. Then equals to the forces going down is this our 20 kilonewton here. This is our 20 kilonewton. I can make it what's your equation 1. Now moving to the step 2. This is step 2, and we can now for the step 2 we are going to find your reaction by taking moments either from RA or RB. Now remember, moment is equals to force times distance. Now I'm going to solve this problem in both sides. I'm going to solve for RA and also for RB. So in case you have any in case I'm giving this problem in class, you can either do the RA or do the RB, but for the sake of the lessons I have to do the both so that we can catch it up as we go. All right, come in, let me let me bring back our drawing to the front. I have to bring out the diagram to the surface. And so now let's start calculating. For our RA, we are taking our moment. Since we are taking our moment from this RA here, so remember moment is force times distance. Therefore, our force here is RA, which is unknown, and our distance is 0. So it's going to, our distance here is 0 because we are taking moment at this place. So it's going to be RA times 0, then plus, remember the ones going, the force is going up are always positive, then the ones coming down are negative. So we are going to have RA times 0, then plus RB. Now the distance from RB to RA is 6, so it's going to be RB times 6, then equal to force coming downward is 20 kilonewton. The distance from 20 kilonewton to RA is 3, so it's going to be 20 times 3. Now RA times 0 is 0, so it's out. So we have RB times 6 equals 20 times 3 is 60. So by making we want to make RB subject of formula, therefore we have to take this, we have to divide both sides by 6. If we divide both sides by 6, 6 will cancel 6, and the other one, the other part of the 6 will go the other side. So that is how we got this 60 over 6, and then 6 cancel 6 on this side. Then 60 divided by 6 will now have 10 kilonewton left. So therefore we have our RB as 10 kilonewton. Then using from the equation we have, from the equation here we say RA from the equation here we say RA plus RB is equals 20 kilonewton, making it equation 1. Therefore we bring back our equation 1, which is the sum, bring back our equation 1, which is the RA plus RB equals 20 kilonewton. Then what we have here, our RB is 10 kilonewton, so we have to substitute and make our RB here as 10 kilonewton. Then we now have RA plus 10 equals 20 kilonewton. Then we want to make this RA subject of formula. By making it subject of formula, we have to move this we have to move our 10 to cross this equation sign, and once you cross this equal sign, it's going to turn into negative sign. So we are now having RA is equals 20 minus 10. 20 minus 10 will make our RA equals what, 10 kilonewton. So that's for that. Then for RB, in case you want to work for RB, this is how it's being done. Okay, let me move my okay, it's too big, it's covering the space. Let me reduce it small. Okay, our RB, this is our RB here. We are taking moment at RB, and since we are taking moment at RB, we're going to have RB times 0. That is the force, which is the RB times the distance there is 0. Then plus, why is positive? Because it's going upward, so it's going to be RA times the distance from RA to RB is 6, so it's going to be times 6, then equal to this 20 kilonewton coming downward is negative, so it's going to be 20 kilonewton multiplied by the distance from 20 kilonewton to my RB is 3, so it's going to be 20 multiplied by 3. So our RB times 0 is out, and we have RA times 6 equals 60, we got our 60 from this 20 times 3. So RA, by making RA subject of formula, is going to become 60 divided by 6, because we divide both side by 6. We divide both side by 6, so this is what we are going to have, because 6 is going to cancel this 6, and then we have 60 divided by 6, which is this. And also, once we divide the 60 by 6, we are going to have 10 kilonewton. Okay, going further from our equation 1, remember we have RA plus RB equals 20 kilonewton. Now, by substituting our RA, which is 10 kilonewton, into this RA here, we are going to have 10 kilonewton plus RB equals 20 kilonewton. Making RB subject of formula, we have to cross this 10 kilonewton down over this equal sign, and it's going to turn to negative. And once it's done to negative, 20 will now subtract 10, and we'll have 10 kilonewton left. So our RB now become 10 kilonewton. In step 3, we have the shear force calculation, and we also have the bending moment calculation, which is the first time distance. Now we are going to start with the shear force calculation before we get to the bending moment calculation. Let me bring out my diagram. My diagram should be at the front here, because it will be easier for me to explain with the diagram. For our shear force calculation, at RA is equals 10 kilonewton. Remember when we got our 10 kilonewton, then our at C, which is at this point here at C, is going to become RA minus C. Remember, RA is going upward. So it's going to be upward direction minus the downward direction. So all about this shear force here is all about addition and subtraction, so it's nothing much difficult for you to understand it. Our RA here is 10 kilonewton minus 20 kilonewton. Why is negative? Because it's coming downward. So 10 minus 20 will have minus 10. When we draw the diagram, the shear force and bending moment diagram, when I get to the shear force and bending moment diagram, you are going to see how it's being done. Then for at RB, we have RA, which is this one here, minus the 20 kilonewton, which is coming, minus the 20 kilonewton, which is pushing the beam downward. Then our RB is also pushing the beam upward, which makes it positive. So that is how we got this one here. So our RA is 10 kilonewton minus 20 kilonewton from this C, at this minus 20 kilonewton. Then our RB is 10 kilonewton. So let's see. So by the time you multiply everything, 10 plus 10 is 20. Then take it away from this 20, we have 0 kilonewton. Then checking our shear force and bending moment diagram. This is our shear force and bending moment diagram. So remember, we have our RA as 10 kilonewton. Initially it was 0 kilonewton. Then a force is applied from our reaction A, which boosts it to 10 kilonewton. Then since there is no UDL here, it's going to be on a straight line. Then I will now have force at C, which is 20 kilonewton, which push it down. Here makes it 10 kilonewton. Then another 10 kilonewton. I did it on 5 by 5 um 5 units. I did it 5 units. That is from here to here is 5, then from here to here is 5, which is 10. You can also get your units on your graph papers too. Okay, then we also have 20 kilonewton pushing it downward and gets to here and turn becomes what, minus 10 at this point here. So at this point here it becomes minus 10. Then since there is no UDL here, we are going to draw a straight line, and our ROB here is also 10 kilonewton, which then push it and we end at 0. When solving your shear force and bending moment, and you find out that the problem, your final answer didn't end at 0, you will know that your answers are wrong, because it must end in 0. So let's go to the bending moment. Alright, let me move my diagram this way. Now the bending moment calculation. Okay, our bending moment is all about force times distance, so we are going to multiply the force and the distance together. So at RA is going to be 0, because the force here, when taking your moment at RA, which is at this point here, we have the force, which is 10 kilonewton, multiplied by the distance of 0 kilonewton. So we are going to have 0 kilonewton. When taking moment at C, which is this point, we are going to have RA multiplied by the distance from RA to C is 3 kilonewton. So we are going to have RA multiplied by 3. Then since it's negative, we are going to have minus 20 multiplied by a distance of 0 kilonewton. Remember, these are 20. That is where you are taking the moment from. So it have a distance of 0 kilonewton at that moment. So by the time we multiply our RA, which is 10 multiplied by 3, this one is also automatic 0. So we are going to have 30 kilonewton as that is our bending moment at this point here. See, so going down, we are going to take our moment at RB. Now we are going to take our moment at RB, which is next. Now moment at RB is going to be RA multiplied by the distance 6. RA here multiplied by the distance from RA to RB is 6 meters. So then our 20 kilonewton, which is pulling it downward, is going to be negative. So it's going to be negative 20 multiplied by the distance from 20 to RB is 3 meters. So it's going to be 20 multiplied by 3. Then our RB here is going to be RB multiplied by 0. The distance here is 0. And therefore, if you calculate everything, we're going to have our RA here is going to be 10 multiplied by the distance 6. Then our 20 multiplied by the distance 3. This one is automatic 0. So by the time multiply 10 times 6, we are going to have 60. Then 20 times 3, we are going to have 60. 60 minus 60 is 0 kilonewton. So our bending moments end in 0. That makes it correct, same as our shear force calculation. So checking the bending moment diagram. Checking the bending moment diagram. At this point it was 0 kilonewton. Then when it moves to this point 30, which is at C here, 30 kilonewton. Then at RB became 0 kilonewton. So if we check it, it will show you that this is 0 kilonewton at RB. At RA is 0 kilonewton. Then at C is 30. Therefore here is 30. and our maximum bending moment here is 30 kilo newton. Now let's go to example 2. Shear force and bending moment, episode 1, example 2.